Hey guys, welcome to video lesson 3.2. This is adding and subtracting linear expressions. So we're still dealing with expressions in this video. So remember, none of these problems will have an equal sign. So we're just going to be able to answer the following questions today. How can you add or subtract algebraic expressions? What you're going to need is your outline or your notebook, your pencil, and remember to pause at any point in time that you need. There are going to be a total of 5 pages, this page being 1. Okay, we're on page 2 of 5. So please copy this definition down and pause where you need. A linear expression is an algebraic expression in which, down a little bit, in which the exponent of the variable is 1. I know that sounds a little wordy to you right now, but I will show you some examples in just a second. So a linear expression is an algebraic expression in which the exponent of the variable is 1. Okay. So here are going to be some examples of linear expressions and examples of nonlinear expressions. So negative 4x is a linear expression. So you see the variable here? It doesn't have an exponent, so it's understood that it's 1. So this would be linear. 3x plus 5. Here's the variable. There's no exponent, so it's understood to be 1. And the last example, 5 minus 1 over 6x. Again, here's our variable. It's understood that the exponent is 1. So some nonlinear expressions would be x squared. So you see how the variable has an exponent of 2? That would be nonlinear. If you graph this, you're not going to get a line. 7x to the third power, this variable has a power that's greater than 1. So this entire expression is not linear. And finally, x to the 5th power plus 1. Again, nonlinear. If I graph this, you are not going to get a line because the exponent here is not 1. So I'm going to show you 2 different ways of how to add linear expressions, and you pick whichever method you like better. I'm not going to force you to do it one way or the other. So the first way to solve x minus 2 plus 3x plus 8, notice that there's a plus sign between parenthesis 1 and parenthesis 2. We really don't need those parentheses because everything across all of this is plus and minus. So what we can do, the vertical method, is take the top expression and line it up with the bottom one. So you notice my constants are lined up and my variables are lined up. So x plus 3x is 4x. I'm going to put a plus sign. Now remember, this is negative 2 because if I rewrite minus, it's the same as x plus negative 2. My 2 is negative. So negative 2 plus 8 is 6. Okay, so that's one way. Our second way, or option B, it's called the horizontal method. And you don't need to write these words down, it's okay. So here's the problem, negative 4y plus 3 plus 11y minus 5. So if you just take a look at the problem, you notice that everything's either being added or subtracted. There's no other operation. So I'm taking this and I'm adding it to that, plus and minus. So what I'm going to do is first rewrite the problem without any parentheses. Now what I'm going to show you on the right side here are just steps. Write them down to help you in case you get stuck in class when we do classwork. So I'm going to rewrite the sum. What I'm going to do here is put all of my y's together. So you notice I took this 11y, positive 11y, and I moved it here. So that means I'm going to take the rest of the problem, plus 3 and then minus 5. Now there's some of you out there who like to take all the negatives and rewrite it, and you can do that as well. So you would use the add the opposite rule. So it would look like this: negative 4y plus 3 plus 11y plus negative 5. And so when you rewrite it, you would get negative 4y plus 11y plus 3 plus negative 5. Okay, so you can continue that way. So instead of doing this row up here and this row here, you can do what I just showed you here. It's the same exact thing. Okay, what we're going to do next, I personally don't do this step because I don't think it's helping you in any way. What I do from here is I look at my two like signs, so negative 4y plus 11. So since we have the same variable, I just put these together. So negative 4 plus 11 have different signs. So I would subtract 11 minus 4, which would be 7y plus, and then I would look at my constants here, and since my signs are different, I'm going to subtract. So unit 1 still hasn't gone away. 5 minus 3 is 2, and since the 5 gives a bigger absolute, it's plus negative 2. And if you notice here, that's the answer that we have. Now 5 plus negative 2 is just the same as 7y minus 2. So it's exactly the same. So I will take this answer or this answer. This step here, don't even bother with that. Okay, let's do a few more examples. What I'd like you to do is try examples A, B, C, and D. And when you're ready, I will go through them. So pause now. Try to at least do one of these on your own and see how you're doing. Just be careful with C and D because there is a minus sign between the two problems, and that does change things a little bit. So when you're ready, unpause the video and go through the solutions with me. Okay, so for example A, we're going to take 2x plus 1 plus x minus 1. Now what I'm going to do is rewrite my my variables first, plus, and then I'm going to take my constants second. I'm going to do variables first, constants second. So 2x plus x, remember, when it's just x, there's a 1 in front of it. So that's 3x plus, well, plus 1 minus 1, these are inverses of each other, so they equal 0. So I can write 3x plus 0, or I can reduce it down and just write 3x. Okay, I will be erasing this board, so if you need to copy, please pause now. Okay, here's example B. We have 2x minus 6 plus 3x plus 2. Okay, once again, I'm going to write my variables first, so 2x plus 3x, and then I'm going to write my constant second, so minus 6 plus 2. I am going to combine my variables to get 5x, and at this point, minus 6 plus 2, it's the same as if I change this to plus, and I change this to opposite. Okay, and now I'm going to combine those two. So 5x plus negative 6 plus 2 is negative 4 because my signs are different. Okay, at this point, I'm going to erase the screen. If you need be, pause. So here's example C. Now remember, example C and D, I should be careful because there is a little bit of difference. So 2x plus 4, you guys see this minus sign? It's saying take the opposite of everything in there. So it's going to become minus x. See that plus 2? it becomes its opposite, it becomes minus 2. So what I'm going to do now is rewrite all these minus signs, this one and this one, as plus opposite. So 2x plus 4, I'm going to make this a plus. I'm going to make this opposite, so negative 1x. Remember, x is the same as 1x. And I'm going to make this plus, and I'm going to make this its opposite, so negative 2. Now what I'm going to do is take my variables and write them together. So 2x plus negative 1x. And I'm going to take my constants and write them together. So plus 4 plus negative 2. Now from here, I'm going to combine my variables. So 2 plus negative 1 is 1x plus, and then here, 4 plus negative 2 is 2. So since my signs are different, I subtract. This would be the final answer. So if you have trouble with C, why don't you pause here and try D on your own? I'll be erasing the board now. Okay, here's example D. So we keep the first term, so 4x plus 3. And when I see that minus sign, I'm going to change and make everything the opposite. So it becomes minus 2x. Now you see how the next thing says minus 1? I'm just going to write it as plus 1. Okay. So I'm going to rewrite this minus sign. So 4x plus 3 plus, this becomes plus, this becomes opposite, negative 2x, and then plus 1. Right, what I'm going to do now is combine my variables. So 4x plus negative 2x, and I'm going to take my constant plus 3 plus 1. Now I'm going to combine 4 minus 2 is 2x, and 3 plus 1 is positive 4. There's my solution. If you're having trouble, it's okay. We'll be spending plenty of time on this tomorrow in class. And we have just one more page to do at this point. Okay, so for this last example, we have an example where the distributive property needs to be used before we solve. So just a quick reminder, remember to distribute, we're going to take this outside number and multiply it to each of the inside numbers. So I want 2 times this amount, and I want 2 times that amount. Okay, once the parenthesis comes to an end, the distributive property is over. So the distributive property ends at the 3. So the way this is going to go is 15z, because I took 2 and I times it to 7.5. Then I'm going to bring my plus sign over, and then 2 times 3 gives me 6. Okay, and then at the plus sign, I bring that over, and I copy 5z minus 2. Okay, and this step is the distributive property step. So anything that you see coming up in this light blue is just explaining what the steps are. So what I'm going to do from here is bring my like variables over, so negative 15z plus 5z, and then 6 minus 2. Remember, you can write the minus as plus negative 2. So I'm using the commutative property. So anytime I move stuff around, I'm commuting them just like you would commute to and from school. You're just moving to and from. So my final solution, I'm going to take negative 15 and 5z. So I'm going to take 15 and 5 and subtract because my signs are different. So I get negative 10z plus 6 minus 2, or 6 plus negative 2 is a 4. And that's my combining like term step. All right, thanks for your patience and participation. Complete your assessment, and I will see you guys tomorrow.